Hello everyone, I hope you're having a great weekend. During this video we will be talking about ratios. So let's start by explaining what ratios are. Ratios are a relationship between two quantities. And what do I mean by that? Let's take an example involving a classroom. Let's say that we're going to have two quantities, students and teachers. So the amount of students in a classroom and the amount of teachers in a classroom. Okay? So let's say that for every 15 students, there should be 2 teachers. Okay? This is the ratio between the students and the teachers. That would be, if I wanted to write it as a fraction, that would be 15 over 2. Now let's take this to the scale of the school. Let's say that in the entire school, there are not 15, but rather 300 students. But the ratio between students and teachers is the same. How would I use that to find the amount of teachers? That's the unknown here, the amount of teachers. If the students are 300, how many are the teachers in order for the ratio to stay the same? And I do that by saying that the cross products need to be equal. So 15 times x needs to be equal to 2 times 300. Okay, let's take that into an equation. 15 times x needs to be equal to 2 times 300. I know that 2 times 300 is 600. And this, the 15 times x, is going to stay the same. So I'm going to have that 15 times x is equal to 600. So if you remember from equations these past few weeks, my goal is to get x alone on one side of the equal sign. To do that here, I would have to divide by 15. I would have to divide both sides by 15. Can't divide just one side. And so these 15s cross each other out. And I'm left with x is equal to 600 over 15, which if you calculate that, that's 40. And so I found the unknown, the amount of teachers in the school that has 300 students is 40. Sorry about that. Again, I did that by making sure that the cross product is equal. So 15 times x needed to be equal with 2 times 300. That is for normal ratios. If you look at the quantities here, let's put in what we found. The teachers are 40. If you look at both quantities, they have both become greater. 15 became 300 and 2 became 40. So they have both gotten greater. If they were to get smaller, this can't happen here, but if they were to get smaller, they would both have to get smaller. If there were fewer students, there would also have to be fewer teachers. We can have another case which is called an inverse ratio. And what happens there is that as one quantity becomes greater, the other quantity needs to become smaller, or vice versa. So to give an example of that, we're going to take two quantities. The amount of painters needed to paint a wall and the amount of days it takes them to finish painting the wall. So if you think about this, the more painters there are, the fewer days they're going to need to paint that wall. Or if there are fewer painters, they're going to need more days. So let's say that I have 6 painters who would take 27 days to finish painting my wall. And then what happens is that 3 more come along, and now there are 9 painters. And I want to figure out how many days it's going to take them to finish painting the wall. So my unknown is the amount of days. So before we talked about the cross product and how it had to be equal. But this time, these are the products that need to be equal. Because we have an inverse ratio instead of a normal ratio. So that would be 6 times 27 would have to be equal to 9 times x. And if you calculate this the same way that we did before, what you would end up with is 18 is equal to x. You would do that by doing 6 times 27, and then whatever you would find, you'd need to divide that. You'd need to divide both sides by 9, and you'd get 19, and you'd get 18. So x equals 18. So remember, when we have a normal ratio, like we had here, the cross products need to be equal, like this. But when it's an inverse ratio, these products need to be equal instead. And that's all. And see you on Monday.